a bell ringer. Y'all ready? Y'all ready? Let's go. Come on. Michael, we ready?
Yes.
We had a bell ringer the other day where we discussed some vocab a little bit. I'm going to give you 4 looks here. That says 9x is 10. This says 9x plus 10. This one says 3 plus 5x minus 8 plus 9. And then here I've got 3 plus 5x equals negative 8x plus 9. Okay, so we got 4 problems we're going to talk about and discuss. First, linear equations. Just plunk it. First, is number 1 an equation or an expression? It's an equation. Good answer over here on this side of the room. It's an equation. Difference between our answers on these, if we have an equation, we can actually solve. And we talked about that the other day on the bell ringer. If we have an expression, sometimes we'll be able to simplify, sometimes we won't. Okay, but number 1 is an equation, so I'm going to label that an equation. Now I can solve that. It's got an equal sign. It may not always be a pretty answer, and this one's one when it's not. Because those that get your notes one, I would have to divide by 9. So I'm just going to leave that as 10 ninths. Okay? Everybody good on that? You could put it as 1 point, whatever. What is it, Baylor, as a decimal? I think you were dividing over there, weren't you? No? 10 divided by 9, yeah. 1.1 or 2, yeah. All right, numero dos there. Is that an expression or an equation? What you think on that? Expression. Correctamundo. Now, I told you a second ago, sometimes you can simplify an expression, sometimes you cannot. Can we simplify that one?
No.
No. Y'all are good because there are no what? What's the math word that there's not any of? Say it again. I didn't hear you. That means it's not an equation, but why can't I simplify it? There are no like terms. Good, Miss Rachel, no like terms. We had that on an exit question not long ago, remember? Like terms, remember that? Okay, what we got? This says, this one might be hard to read. This says 3 plus 5x minus 8 plus 9. It's an expression. Aaron is correct. Can we simplify that expression any?
Yeah. A little bit.
A little bit. There are some like terms there. So my like terms, be careful on your signs. I've got 3 minus 8, which is negative 5. Negative 5 plus 9 gives me 4. So there you go. Can't simplify that anymore. I think I had to live. Can't simplify that anymore. That would be it. Oh, I forgot to write it. It's an expression. Let me do that. Okay. What's the 4 in that answer that I just circled? What's the 4 called? Anybody know the mathematical term for the 4 in that? It's got a definition. Very good. Chase, it's the constant. Very good. It is that kind of numbers. I mean, that's right too. I wouldn't smack you for saying that. But in that, if it's a number without a variable, it's called the constant. All right, the last one. Do we think that's an equation or an expression? Equation. Good. So let's see if we can start solving this thing. What would you try to do first? That says 3 plus 5x equals negative 8x plus 9. Subtract the 3. I heard a couple say. I'll go with that. That would leave me with 5x equals negative 8x plus 6. Okay, now we don't have a choice. There's a right thing to do now. What is it? Add 8x. Nice job. This one's not going to be a pretty, oh, I'll put 18. Not going to be a pretty answer either. I was thinking 13 and already going to it. I'm just going to leave it as 13 sixes. Is that, or 6 13s, Bunny? Is that okay?
But if it's a negative, how can it add up if it's negative?
Well, what we're actually doing when we're trying to get rid of it. So I'm saying negative 8 with what would make 0. So that's why I had to add. Negative 8 plus 8 makes a 0.
Okay.
Good. That's a good question. I like it. I like it. All right. So we're just going to now work our way into some equations. We get to the level where we have a variable and 2 constants. And that's what we looked at. And I've said, here we are with a 2-step middle school equation. We're real good at these. Okay, but our stuff that we're going to start with today are going to be a little bit bigger, and we've got to simplify them down to get to that level. So let's look here at 4x plus 8x equals negative 9 plus 17x minus 1. Alright, 4x plus 8x equals negative 9 plus 17x minus 1. Think about, look at it, think about it. Tell me what might be something good to do. Hunter, what do you think something good to do could be here? I could. I don't want to though. Hunter's not wrong. I could subtract the 4x, but I think I would do what Keston said first and go ahead and combine them. If Hunter subtracted the 4x, that'd be okay. Then he would just still have another step to go. So Keston's going to combine those first to cut down on the number of steps. So I'm going to go with Keston like terms. Anytime I've got like terms, I try to combine those first. Okay? On the right side of the equal sign, are there any like terms over there, Aaron? Good, those constants, you can combine those. So we have 17x minus 10. Cool, cool. All right, what would we do there, Michael? We've got a two-step middle school equation. Here, okay, what do we think we do? I could. That's going to add an extra step. Help him out, Baylor.
No, subtract.
Baylor doesn't want to give up.
No,
subtract
17.
Okay, 17 would be the shortest. That's why we're reviewing it. 17 would be the shortest number of steps. If Michael had added 10, it'd just be moving that over there, and there's nothing over there. So then we would still have a variable on both sides. So we tried to get the variables on the same side. So subtracting 17 will be the shortest path. It's not the only right path. Michael's could have eventually worked. 12 minus 17, that makes that a negative. And then we got a negative 10. So you ought to know what x is now, right? Yeah.
That man ever gonna get fixed?
Nope.
Sure.
Till it falls on Michael right there. You know, the even dumber thing about the, I like the fans other than that one wobbles, but the dumber thing even than that is that they're not even wired to be able to use that light. Because I was thinking a lot of times when we're working on overhead, we could turn those lights on and turn the lights off, you know, when we're working on the smart board, but they're not wired for the light. So we got a light up there with no, they didn't hook it up.
Wow.
I mean, I guess maybe they couldn't find one that was just fan, but they do make them.
I could wire it.
We got other lights.
I could put up in the one that really right there for no reason.
That's what I said.
We drove. We do a lot of stuff in the bridge.
Oh, I know.
Hey.
Oh, yeah.
All right, this one I got 6 minus 4 plus m equals 8m minus 2 times 3m plus 5. So we've added the parentheses in this one, both sides on this. That's a new step. And that left side can trick some people. So let's be real careful there on that left side. How would you attack the left side if it were you? What would you?
Take away the parentheses.
The negative switch, or I can't.
Distribute the negative.
Good. All the stuff y'all are trying to spit out is correct. I didn't hear any bad stuff on that. One way to think about it, when first thing I heard Miss Kaylee talking about is lose the parentheses. Yeah, we're going to lose that parentheses, but what we will remember is that when we do that minus sign in front, means we're subtracting everything, which is what the rest of y'all were spitting at me, means that we're going to distribute that there. So that's the same as having 6 minus 4 minus m. And now, can I clean that up any before I move over to the right side? What can I do to that to clean that up?
Combine 6 and 4.
Okay, Miss Keston. So that's what we're looking at. Can I do anything else there on the right? Or that's the left. I do know my right from left some days. Can I do anything else on the left? No. No like terms. We're good. All right, let's jump to the right. To the right. To the right. Alrighty, so let me drop my 8m, and I'm with you on that. That gets me a negative 6m. and a negative 10. Can I clean that up any? Yeah, good, good, good. So what does that make by m's?
210
Good. Now we've got 4 parts, and this is where you get to pick where you want to start, and there's no wrong answer here. You could start with any of the 4 terms. Anybody got a preference? Add the m. That's what I would have done also. I like that. I'll tell you why here after I get it done, but if you didn't start there, you're not wrong. Okay, that would give me 2. This cancels out. 2m and m's 3m minus 10. My personal preference when I've got 4 to choose from like that is I always look at the variables first, and I do whichever way will keep the variable positive. I like my variable positive. Doesn't mean that's the only right way, but that's what I do. So what you do, Hayden, like that. All right, now we got a 2-step middle school equation. We're good at these. What's step uno? Add 10. Good. So I got 12 is 3m. Good, 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 good. Now, I didn't show you this on the last one, but I need to. That's my answer. I always, whatever variable equals whatever, and circle it. That's good. There's another way that you could see a correct answer, just in case you see it different in your college algebra teacher if you take that. Remember last unit when we did the sets? 4 is the set of all numbers that makes that true. So sometimes a teacher might put it in the braces. Okay, I won't do that because I can't draw those good enough. I don't want to draw them every time. But that means the same thing. 4 is what works. 4 is what works. 4 is what works. All right. Climbing up the ladder here. Adding another step. This has got k plus 1 over 2 plus k plus 3 over 4 is equal to 1/2. All right, what this is called, this is still a linear equation, but more specifically, it's a rational equation. Okay, what makes this be rational? What's the deal with it? I remember back, we talked about rational numbers on the second day of school. It's been many moons ago. 12 or something. Yeah, but hold on. You're already working it. I'm just trying to get you to remember a word. Rational. What makes something rational?
Evenly divided.
Could be a fraction. Very good, Chase. So this is called a rational equation because it's got a fraction in it. The first week of school when college algebra started having homework, this is some of the stuff they were bringing me. Okay? This stuff right here. All right. Now, to add and subtract fractions, we learned about the 4th grade, you had to have a common denominator. So I could make a common denominator on all this to start trying to add it, but we're not going to do that. There's an easier way. We're going to just get rid of the fractions. That'll make you excited. Y'all don't ever like fractions.
Yeah.
But to get rid of the fractions, we do got to know what the common denominator would be. So look at our denominators, 2, 4, and 2. What will 2, 4, and 2 all go evenly into? 4. Very good. So we're going to multiply this whole thing by 4. Okay, I'm going to multiply the whole thing by 4. Now, first time when I'm going to break it down and show you part by part. In the future, I may skip this step, but since it's our first one today, I'm going to go ahead and show you. If I distribute a 4 to the first part, to this, that'll be 4 times k plus 1 over 2, right? Now, we looked last week, I was talking about diagonal reducing. 4 over 2 is the same as 2, right? So now that's 2k plus 2. Alright, so if we take a 4 to our second term, I'll have 4 times k plus 3 over 4. I like this one. 4 over 4 is 1, so that doesn't change, does it? Okay, so I'm going to bring down my k plus 3. Tell me where.
You lost it right there at
Okay, we distribute our 4 here, so when I do that, that means I have to take 4 I have to multiply it by k plus 1 over 2, because that's the first one, right?
Or you got that 4 from how many, like, the 2s and the 4?
Right.
Oh,
Right, the common denominator, good. Okay, so when I do this here, Keston, when I multiply this by 4, that's like 4 on the top, and a k plus 1 over 2. 4 over 2 is the same as 2. So then I just distributed my 2 to both of them.
So the 4 over the 2 made
Okay.
2, and then she made 2,
So the outside
where
number
the 4 is.
cross out.
Distributed out to the it's k plus 1.
How did it make a k plus 3?
I'll go over that one again. I mean, Keston's still digesting the first one right now.
I feel like it's so easy. Got lost. You can keep going.
Well, let's look at the second one again, because Zane wants to know too. When I take the 4 to the second one, I've got 4 times k plus 3 over 4. Well, 4 divided by 4 is 1, right? So those 4's just cancel out. So all you're left with is k plus 3. Does that help any, Keston?
I got it now.
All right. We still got one more place to take the 4 to. We have to do 4 times 1/2. So we've got 1/2 times 4. And you know what 1/2 of 4 is. That boy, Hayden. 2. Say it a little bit more
Boy.
confident next time. He's like, 2. 2! Oh, sorry, Rachel. Steer, Rachel. All right. Like term hunting on the left. What do we get with our K's? 3K, Mr. Aaron, is correct. 2 of them and 1 of them will give you 3 of them. What about my constants using that?
5.
Boy, Mr. Plunkett, plus 5. 2-step middle school equation. Step 1 is?
Mine.
Subtract 5.
Yeah. Subtract 5. What's some German or
And
something?
then you got 3k equals negative 3, which k equals negative 3.
I can't even keep up. Y'all are such geniuses.
I know.
Did you get it, Jared?
And everybody else.
I don't need it, but go ahead and put it with you too, in case I got a question or something. Sir? Sir?
Throw stuff on me.
I'm gonna write you a note so we can say,
I don't know.
stick it.
Hey, Caleb. What did you do in this chair?
Yeah, I know.
Looks like I think
That's gonna be a problem when you're taking the ACT. We're gonna have to get you time management.
Where you trying to go straight?
I'm hitting the slate. It's
Right.
right.
Start right here.
Red.
Make that be big.
Anybody else want to strip it on?
I give it.
Give some.
All right. Now the next one looks at decimals, and it talks about, gives us options to cancel the decimals out. That's not something I stress over with you about because y'all are good at using your calculator when decimals give you fits. I've got
That's more.
0.02 times 60 plus 0.04p, that's p is the variable this time, equals 0.03 times 50 plus p. P is that variable. And by the way, when you're working these, if you're ever concerned about, do I gotta use a p? No, you can put an x in there, you can put whatever variable in there that you want. Alright, I'm here and I'm open, so let's tell me what, and you can use common sense on these as well. You can figure 0.02 times 60 out without a calculator, because you know what 2 times 6 is. So, right? What is 0.02 times 60? Anybody know? 1.2. Okay. Still got a 0.04p. Can I combine this left side?
Yeah. Oh, wait.
No.
No, good, Baylor, because I got a P and a not P. Very good. All right, so over here, I need to distribute my .03.
4.5.
Yes, ma'am. And then to the P, just says,
0.03.
Whoa.
yes, ma'am. All right, so now it's the full part, or just has decimals. You don't do it any different. What do you want to attack first here?
The whole numbers.
Subtract 1.2, I heard. Not what I've done, but I'm doing it now, so I can be flexible here. Gives me nothing. 0.04p equals 0.3 plus 0.03p. Now, whoever said subtract 1.2, we're to what I would have done first. Now, what do you have to do here?
Okay.
Good, good. Me and Hayden would have subtracted that 0.03p. So it's almost nothing, you're right. 0.01p equals 0.3. This blue first period's mine when we got the answer to this. Divide by 0.01.
Wait, shouldn't you multiply those so that way you can get your.
Whoa, what?
Like, so that way it'll be 1p instead of just the decimal?
Yes. I like that, Baylor, and you're fixing to confuse a lot of people, but you're correct the way Baylor said that.
God.
Yes, I wrote that wrong. Yeah, I wrote this wrong. This is divided by 0.01. So that brings it to just 30. But still that blue first period. Now what Baylor was saying, and he's correct, and I like it. What could you multiply here to get rid, to make 0.01 become 1? 0.01 is the same as 1/100th, right? Right? So to make 1/100th become 1, you could multiply it by 100. You can always multiply it by its reciprocal. So another option, instead of dividing by 0.01 here, would have been just to multiply by 100. What's 0.3 times 100? Same thing. No, no.
wait.
0.3. 0.3 times 100. So that would have got you the same thing. And remember when you did fractions in middle school, when you were dividing by a fraction, it was actually multiplying by the reciprocal?
Yeah.
So Baylor was right there on that. Good job.
He always tries to. I said.
All right, we got 3 terms that we got to link up with this now. Write these terms down and we'll learn what they mean. Conditional, identity, there's just 3. Contradiction. Okay, all of the equations that we've solved so far today have been conditional because they had one solution. For example, we got an answer just now that said x equals 30. You just get, it's a normal solution, you get a plain old answer. That's called a conditional equation. Okay, just a new word in case you ever hear that in your future. Then that next one, identity, means there are infinite many solutions. And what that might look like when you're working one of these out, and we did this in Algebra 2, you get a true statement. Like you get something that says 7 equals 7. You end up with just a true statement. If there's a variable still in there, it could be x equals x. It's just a true statement. That's an infinite many solution. So we've got a one solution, we've got an infinite, so you ought to know what contradiction is. No solution, very good. And I like to use my symbol for that. That will look, well, you may remember what that looks like when you work the equation out and it's no solution. Good, very good, Chase. You get a false statement. 7 equals 1, something that's dumb, something that's false. Okay, so we got new terms for those, and that's what we're going to use here next. Yep. I got what you need on that? Okay, this one says 5 times x plus 2 minus 2 times x plus 1 is equal to 3x plus 1. All right, our directions say to solve the equation and decide whether it's conditional, identity, or contradiction. So we got to solve it, and then we got to label it one of our new terms there. You bet your boots.
So what does it mean for identity again?
Identity means there's infinite many solutions, so you'll end up with just a true statement, like it'll say 8 equals 8 or something like that.
Okay, so what's the other one?
Contradiction is no solution, so it would be like 8 equals 7, something that's a false statement. And then conditional is one solution. All right. Guess when I was waiting on you, and then you already started it.
Oh, well, I thought you were just talking.
Okay, I'm just picking. All right, so Keston's distributing. Is that what everybody else is doing too? This gets me 5x plus 10. Got a negative 2 to distribute. Negative 2x minus 2. I like to go ahead and clean that up before I mess with the right side. So combine some like terms here. What would your variable be? 5x and negative 2x?
It's not gonna be.
3x, we good? What's my constant?
It's gonna be.
Uh-huh. Okay, can't do anything else, so now I'm going to drop down my right side. 3x plus 1. All right, so we got 4 places that we could start on that, Grace. Where do you want to start? You just put it on it.
Well, I was trying to figure out what we were doing.
Oh, my bad. Don't get mad at me.
Subtract 4.
All right, Grace is subtracting 1. Hayden and I will endure that
Shouldn't that equation be like a
for some of you. And I'll tell you how Baylor saw that in just a second. Okay, now after Grace did that, what would she do next?
Subtract 4.
Good, Kaylee?
And then it's subtract 2.
No, no.
It's 7 equals 0.
Good. Nothing here. 7. Nothing here. So how do we write nothing in math? 0. 7 equals 0. So what do we have when it's 7 equals 0? How do I write my solution? No solution, because it's false, right? What type of equation is that out of those new words? Contradiction. Now, the reason Baylor knew that when we got right here where I put the star, I'll highlight that. The reason he knew that when we got there is because we had the same variable on both sides. 3x and 3x, right? So if 3x is 3x, then these also have to be the same. And they weren't. Does that make sense? That would have made it be infinite if they were. All right, so let's try another one. We got contradiction taken care of. Here I've got x plus 1. I'll do a fraction one so we practice those again. Over 3 plus 2x over 3 equals x plus 1/3. Okay, this one's going to test us on our contradiction, identity, and conditional, but it's also going to let us have another fraction practice. So, what would we multiply that whole thing by to get rid of the fraction? 3. 3 is the common denominator. Everybody agree? So I'm going to multiply this whole equation by 3. Now this one, Keston, is easier because when I take this here, a 3 on top and a 3 on bottom, what's 3 over 3 the same as? 1. So it just cancels it all out. So all you would have left was what's on top. On most of them.
I meant F.
Yes, when I take it here, the 3 and the 3 cancel out, so all I have left is the 2x. Okay, let's clean that side up before we go to the right side. You've got like terms there. X and 2x is 3x. Alright, now on the equal sign, this is the one where it doesn't cancel out. Because that's just 3 times x, so that's 3x. Plus, what's 1/3 times 3? 1. So we have on the left side 3x plus 1. We have on the right side 3x plus 1. Some of y'all now know the answer. Anybody? So it has infinite solutions. Which, what kind of equation is that? Identity. If you didn't realize it yet, how would you have started this? Ray Hayden, subtract 3x 3x plus 3x is nothing, so you would have a 1. 3x plus 3x is nothing, so that one would have a 1. So you would get 1 equals 1. True statement. Infinite solutions. It's an identity. Alright, then the next one. Like, got what you need on that one? Got a couple more, y'all hang in there. I've got 5.
Are you just taking the lead on that?
No, I got a book back here. If I try to make them up on the fly, they never work. They're like the ugliest decimals you've ever seen in your life. It's not good. 5 times 3x plus 1 equals x plus 5. Alright, same thing. We're going to solve it, and then we're going to tell if it's a contradiction, an identity, or conditional. So what would we do to start solving this one? Distribute. So we would have a big old 15x plus 5 equals x plus 5. Now, some people have gotten tricked on this one, but you're not going to. You're not easily tricked. So don't.
Subtract the 5.
Okay, I'm going to go with Keston and subtract the 5. So that leaves me with 15x equals x. This is the first period did that same thing first as well, and they got scared here. They started saying no solution and all kinds of stuff, and that's not true. This one does have a solution. Remember, our goal when we're getting here and we start moving stuff around is we're actually trying to put the variables on one side and the constants on one side, right? So we need to get the variables are not on one side right now. They're split. We need to get them on the same side together. So we would need to move that, subtract that x, and move that over, right? Okay on that? Alright, so subtract my x from both sides. Remember, I said some people will be tricked on this one, not you. That gets me 14x equals what?
0.
And 0 is a number. Just because you see a 0 doesn't mean it's no solution. That happened on that Algebra 2 test today. They got zeros and started writing no solution. You hoodlums, 0 is a number. So we get x equals 0. That's okay.
And it's conditional.
And that is conditional. Good, Miss Kristen. Alright. I'm going to give you a hard one. Let you attack it, and if we do alright, that'll be a wrap. Everybody ready? Got negative and then a bracket. Here I'm throwing a bracket. 6x minus 4x plus 8, close, equals 9 plus 6x plus 3. Okay, want you to solve for x in this. Talk to your table buddy. Get a good answer on it. Just so you're not scared and you don't jump ship, your answer on this is a fraction or a decimal. So if you get a fraction or a decimal, don't think you screwed up. That it is a fraction or a decimal. That's a negative out in front of that bracket. Negative bracket 6x minus quantity of 4x plus 8 equals 9 plus 6x plus 3.
Is there a bracket button?
I don't know. You can't,
There's a little something above the front.
but you can't just type it in like that, sweetie, because of the x.
Oh, yeah.
Yeah. Like,
You said that's just gonna be what?
A fraction or decimal. It's not a whole number.
We'll do it.
Oh man. You screwed up somewhere. Is this supposed to be a fraction?
Yes.
I did what she said.
Oh my. It is supposed to be a fraction?
Uh-huh.
Look at that on there. So what'd you get again?
I did the way you did it.
I think I'm not.
Yeah, I know. That's what we did.
Like this can't be wrong. I got it. Oh, it can't be wrong. And I did, I'm pretty sure I got it.
Where'd you get plus 6?
Huh?
One of the 3 and 9. 12, not.
Nope, I'm not.
Go try. You tell me a yes or no if I got it. If I can tell you.
Yeah, you subtract 8 though.
I like to add.
I'll draw.
You're right?
Yep.
What'd you get?
Hang on, let me see this.
Wait, so you're not right?
I don't know where.
You're done.
Oh, no.
Where'd I mess up?
You would now subtract 12. If you add it, you didn't get rid of it.
I figured out where I messed up.
This seemed right, but it didn't work however it worked out. But I saw that you got that.
Well,
And
That-
it seems to be right. If
well,
it
it's that negative out in front of the whole thing is what you tried to put that in there first, and that's what's throwing you off.
Oh no, I put it in that bracket. Like I put the parentheses that's in the brackets. I did that one first.
Right,
I
that's good.
distributed the negative. Whenever I distributed that negative,
Hey, you were
it
right.
made that 6. Or, but anyways, how I did it was it made that 6 positive for me, and then that negative 4 was already a negative, so it made it a positive, and then that 8 a positive. So I just worked it from there. I mean, Worked out.
Well, but you just said that 6 needs to be a negative, so that's gonna change everything. But that wasn't bad, your thought process.
Is there an exit question?
No, we're fixing to just go over this one and that'll be it. And we will get your test taken care of, don't stress, we will. I know you're gonna be still staying on it, so. Alright, I'm gonna go ahead, I saw some of you with it, I saw some of you on the right road, but I'm gonna go ahead so we can get it done before we head on now. I got what I did first, and it's a little bit different than the way Baylor started, but he was not on a bad path there. What I did first was in the brackets, so that'll be 6x minus 4x minus 8, right? Then that got me 2x minus 8, right? Now I have that negative outside, so that's going to make that be a negative 2x and a positive 8. How about that? Is that all right?
Yeah.
Okay, over here, I had people first period want to distribute the 9. There's a plus sign, you don't distribute. So that's just going to be a 6x and a 12. Right? Good on that?
Yeah.
Okay, so now we're to the easy stuff. Hayden, what would you do first, Chuck?
So, okay, I do.
Okay,
2x. 2x.
so 8 is 8x plus 12. Then Hayden doesn't have a choice.
Just round it up. I added 12.
Yep, subtract 12.
Brain part.
So negative 4 is 8x. So there is negative half or negative 0.5. I saw both of
Right
them.
there as well. Because I ended up with the answer, but it wasn't no
Yeah.
fraction.
Yeah, that's how Baylor had it too, because he missed one little sign, messed him up. All right, good job. We're going to be linear.